Okay, hello teacher. My name is Nguyễn Thanh Bình from class 22 GP1. I'm a member of group 3 and today I will present lab 2 and I will talk about what is CPU, the component of the CPU, and then I will practice the exercise in lab 2. So now let's move to the first question. What is CPU? CPU here stands for Central Processing Unit. Is the primary component of the computer that performs most of calculation and execute instructions of computer program. It is often referred to as the brain of the CPU of the computer. The CPU interprets and carry out the basic instructions that drive the computer operation. Modern CPU are built with multi-core, allowing them to perform tasks in parallel. This is known as multi-threading or multi-core processing, which improves the overall performance of the computer by executing multi-instructions simultaneously. The CPU works in conjunction with another component of the computer, such as memory, storage device, and input-output device to carry out the computation and manage the flow of the data in the system. It plays a crucial role in determining the overall speed and performance of a computer. And CPU also has some subcomponents that help in carrying out the processing of the task. The first one is arithmetic logic unit, or we call it ALU. The arithmetic and mathematical calculation and operation are performed by ALUs as addition, subtraction, division, and multiplication. It also performs some logical operations including the syntax. And then a control unit, or we call it CU. Its name suggests it controls and guide the interpretation, flow, and manipulation of data and information. Another big function of CU is program execution. And the last one is the register. Registers are passive memory, even faster than active memory. Easily located inside the CPU. They are small and temporary memory units for holding data. CPU store important processing information of the data and register during the time of processing. Memory address and instruction can also be stored in register. And now I will practice the exercise in lab 2. And now I will open the program that I created like lab 2. Okay, as you can see here is register bar. ACC here, it stands for accumulator, is used to store the result of calculation or comparison. When a calculation or comparison is executed, the result is stored in ACC. This result can be used in further calculation or comparison. And here IR here stands for instruction register, used to store the opcode of the current command being executed. This opcode tells the CPU what action to take. And here's the MAR. MAR here stands for memory address register. It used to store the address of the data that need to be read or written by memory. MDR here stands for memory data register. used to store the data read from memory or data written to memory. And then PC is program counter, is used to track the location of running program when an instruction is executed. The PC is updated to indicate the address of next instruction that needs to be executed. And here you can see the memory or the main memory here. We had two columns, that address column here is used to store the address, and data column used to store data. And here in lab 2 we said that the word length for data instruction is 32 bit, meaning one word equals 4 bytes. An instruction word consists of 8 bit of course and 24 bits address. Therefore, the PC and the MAR register are 24 bit long. The status register stores the state of the CPU. And in lab 2 there are few code snippets of the program to calculate the sum of positive number until it encounter a negative number like lab 1, and then it will write the final result of sum here, sum of the positive number, and bring it into the screen. And then after we load the program, after we load the program, the instruction will be stored in memory with each instruction being for address. For example, 000 here is read instruction, and then 4 here is 0 1 3 4 0 1 0 here is dump instruction. And we have some variable storage instruction on the last line. And now I will run step by instruction to see how can the CPU process the program. Here first, MAR will store the address from PC, and then from that we can get data to MDR, and then transfer it into IRCD code here. The ACC here will store the value of the like this. If I enter 1 here, and AC will store the value of that I was enters here. Now the instruction is done here because I enter a positive number, so we skip the instruction and move to the instruction. Here the instruction here, the MAR will store the address of the variable sum here, and then MAR will get the value of variable sum and get the data of variable of that instruction and store it into IRCD code here. No, I will the MAR will store the address of variable sum, and then MDR here will get the data from the MAR the ACC here will add with the MDR to get new sum and store it in ACC, and then store it back to the memory here. And let's move to the next is jump start here. It allow the PC to point to the aspect of risk injection E000 here. And then now I will enter a negative number to end the program, and I will move to run it by micro injection to see clearly how can the CPU process. Now I will enter negative number here. Because I enter a negative number, so the PC will store the address of the injection lot sum here, and then it will write the final result to the screen. That's the one lot sum, and then write it into the screen. Now I will stop the program and I will run it by micro injection. Okay, now I will run it by micro here. MAR will get the address from PC. MAR here, the console 000 here, and then from MAR, MDR will get the data from memory and transfer it into IR to decode here. And then PC will store the address of net injection, or that's 0100 here, and store it into PC here, and then decode here. The micro injection here allows user to enter a number, to enter an integer here, and 2. In the PC, MAR will store the address of the net injection the PC hold here, and then from that MDR will get the data from memory and transfer it into IR. Really nothing to say here. Now we can move to the decode. Because I enter a positive number, so we skip the injection and move to the end. And now is add injection. Here decode here. The MDR will store the address of this variable sum here, and then MDR will store the value from memories. Store the value from memory. And then we can see here ACC will plus with MDR and get the new value and store it back to ACC. And then it store then we will store the ACC into MDR, and from MDR we store it that value back to the memories. Here you can see here ACC will store the value to the MDR, and then from MDR we store that value to memories, and that's the end of store instruction. And then we do the instruction here. That's the PC point to the bridge instruction that with address 00000. Yeah. Now I will enter 1. You see the sum here clearly. Yeah, as sum here we get the value of the memory here. Here we get the value from memory to MDR. The values in here is true, and then true plus with 1 here. We will get the new result is 3 and store it in ACC. The 0011 here is 3, mean 3. And then we will store this value to the memories here. MAR get the value, get the address of some variable, and then ACC will store that value into MDR and store it back to the memories. Now I will enter a negative number to end the program. Now because I enter a negative number, so we must do this instruction that PC will store the value of log. We will move to the done of the program. PC will store the address of sum here, and then MAR will get the address from PC, and then from that we will get the data from memory to MDR. Yeah. We load the sum to ACC, and then we bring out the final result to the screen. Here, MDR. Get the data to MDR and then transfers into ACC here to bring out the final result. Now it will write the final result. Here, the final result here is 3. Here from AC. The end of my presentation. Thank you for listening.